Hey guys, we're back at it. 2019 at Maths, paper 1. The expression x minus 2 is a factor of. Now, let me just pull this up on the side here as well, so we will be able to have all of our I will be able to see this live with all you, right? So give me a second. 2019 paper 1. So in the event that some of the things is not as clear on the screen here, I will just tell you what it is, right? Oh god, it's even not as clear, but it's still legible. Now, all I'm gonna do, I'm gonna just solve the polynomials of degree 3 and see if 2 is a solution. And I'm gonna use my calculator to do that. So mode 2, 3. 4x cubed plus 2x squared minus 16, that is part B. If these does not have a solution where 2 is the answer, I will just substitute 2 into A and D because A and D is polynomials of degree 4 and I don't have that function on my calculator. So A is 4, attesting B. Alright, then the coefficient of x squared is 2. We have no x term and we have the constant to be negative 16. No. And the next two roots are imaginary, so that's not working there. Let's check C, 2, minus 4, and minus 8. No. So let's now go and check to see if 2 works for the easier function, which is A. So we have 4 into 2 to the power 4. Take away 2 into 2 squared, take away 56. It does work for A, so A is the answer. Let me see if I can make this a bit bigger for us to see what's going on. I think, yeah, that working. When this is divided by x plus 2, the quotient is, now they never ask for the remainder. They ask for the quotient. So let me just go through the long division and whatever end up on top, that is what I want, right? So we have x plus 2. And we have the square root, well, not square root, but divided. It's x cubed minus 7x squared plus 2x take away 1. First inside, divided by the first term outside. X cubed divided by x is x squared. So I've seen two of these things have x squared in it. So once I narrow down the coefficient of x, I get my answer. X squared by x is x cubed. X squared by 2 is 2x squared. And I've taken away these two terms from each other. I'm going to get 0. 7 minus 2 is minus 9x squared. So I'm going to get minus 9x. So the answer is D, without even going any further. Given that f of x is equal to that, oh god, oh geed. All right, now this here, right? Some of you all know the formulas for completing a square. You say A is A. I believe you all will use H is minus B over 2A and K is C minus A H squared. And yeah, it works only if I have numbers inside of there. It will work for this question as well, but it will be a little more difficult. So what I do, I go through the old-fashioned way where I forced the perfect square inside of a quadratic. So I'm going to have A into x squared plus B over A x plus half of this is going to be B over 2A squared plus C take away A into B over 2A all squared. So I'm going to end up with A into x plus B over 2A all squared. X plus B over 2A all squared. So we have the first pieces settled down here. So it could be any one of the answers. I had to simplify this here. I'm going to get C take away A B squared over 4A squared. So this could cancel with this here. And I go and calculate my LCM. I get 4AC take away B squared all over 4A. 4AC take away B squared over 4A, and it's going to be plus. So the answer is C. This is a nice question. Very, very nice question. If I was CXC, I would bring this question every year. Which of the following best represents f of x is x into 1 minus x? Now the coefficient of x squared is going to be negative, which means it could either be b or d. If I put this as equal to 0, I'm going to get x is equal to 0 and 1 minus x is equal to 0. Moving the x across, I get 1 is equal to x. So my two x-intercepts are 1 and a 0, so the answer for this is B. Right, so I'll just change the color and I'll use a brighter color, right? The values of x for which this are, oh God, we can't get away from it here, right? We're going to have to go ahead and expand and go ahead and solve. Now expanding this is a small thing. Some of you might want to go and take the square root of both sides. And if you go and take the square root of this here, then go say, well, no, so the square root of 64x, which is 8x. That's wrong. That's 64 root x if that's the answer you want. Expanding the left-hand side, I'm going to get x squared plus 30x plus 15 by 15 is what, boy? I just like to make sure my calculator. 225. If I move the 64 across, it becomes minus 64. So 30 minus 64 is what? Minus 34. So I get an x squared minus 34x plus 225. And I could solve this on my calculator. A is 1, B is minus 34, and C is 225. 25 and 9 is the answer. The range of values for which this is less than 0, well, this is a positive x squared. Less than 0 is going to be down here. And the range of values could either be A or B. Solving the quadratic, 1 minus 7 and 10. I get in 5 and 2. So U is 2 and U is 5. So the range of values is going to be less than, so the answer is B. And I didn't even have to solve it. This is the only the only solution where the range of values could be in between over here. The set of values of x for which this is more than or equal to 0. The paper 2 way for this is multiply by the square of the denominator. Go ahead and solve. The paper 1 solution to this, you could take that approach as well, or you could just solve the numerator, solve the denominator is equal to 0. When I solve the numerator is equal to 0, I'm going to get x is equal to, move the 1 across, minus 1, divide by 2. When I solve the denominator is equal to 0, I get 1. This here is going to be a positive x squared. We have minus a half and we have 1. And we want where this is greater than or equal to 0, could be above. It's going to be less than minus a half, less than minus a half, and more than 1. Why do I have more than minus a half and more than 1? All right. For sure, it cannot be 1, right? Because of the nature of the denominator, it cannot be 1. It cannot be equal to 1. So it have to be this. But why is it saying less than a half? It's supposed to be less than minus a half. So I believe this question here has a little error in it. It can't be 1 for sure, and minus a half definitely works for this function to be more than or equal to 0. All right, nevertheless, based on the process of elimination, D is the best option in this case. We come across another instance here, like what we talked about before, where we want to get the range of the function. Again, luckily, this function here, by substituting the both extremities, minus 3 and 3, we will get it happening because we're supposed to know how x cubed does look. X cubed has no turning points. It just have an inflection point. So go on your calculator and plug in negative 2/9 into minus 3 cubed. I get 6. And we want 3 cubed now. So I'll just delete the minus sign. I get minus 6. Now the minus 6 will have to come first because the smaller number always comes first. So it's between minus 6 and 6. The answer is C. And just to give you all a little sneak peek of how the graph does look, let me pull it up here right now. It was minus 2/9 x cubed between minus 3 and 3. Less than or equal to 3. Right, so the extremities are minus 6 and 6. Cool. Let me just make this a little bit bigger so that in the event that I want to show this something again, we have it big and bold. Wonderful. Number 9, the functions f and g are defined as follows. The function f g of x is given by, all right, so we want f g of x is 2x plus 1. That is f g of x I now write down here, which is 2x plus 1 over 2x plus 1 minus 1. This is 2x plus 2 over 2x. Bam, bam, bam. I get x plus 1 over x. X plus 1 over x. The answer is A. Now, I did not know if this extra step was necessary. Again, like I said in the previous solution for 2018, watch all your options first. Because for all we know, one of the options could have been 2x plus 2 over 2x. That could have been an option, and I didn't have to go and simplify it. The function that then m of 4 minus 2a is going to be 5 plus 2 into 4 minus 2a, 5 plus 8 minus 4a, 8 and 5 I believe is 13, 13 take away 4a is my answer. If f inverse x is such that x is mapped onto x squared minus 1, then f of x, so the inverse of our inverse is the function itself. So I will let y be equal to x squared minus 1, interchange the x and y, x is equal to y squared minus 1, move the 1 across, x plus 1, square root both sides is equal to y. So square root of x plus 1 will be the function f of x. X plus 1, right? Answer is B. This simplifies to, you can just plug this straight into your calculator. 2 to the power minus 1, and I'll put that in a bracket, 2 to the power minus 1, divided by, open bracket, 8 to the power 1/3. Close bracket, 0.25 or a quarter. If you wanted to use your laws of indices, you will come below. You will stay here, but use the cube root. So when you come below, you become 1 over 2, and the cube root of 8 is 2. You get 1 over 4. If log of x to base p is 6 and log of y to base p is 4, log of x over y, that is a takeaway. So that's going to be log of x take away log of y, 6 take away 4 is equal to 2. Given that 3 multiplied by 27 to the power 2x, that's 27 to the power 2x, right? Let me check back here. This is number 14 we on. Yeah, that's 27 to the power 2x. So we have 3 multiplied by 27 is 3 cubed to the power 2x. And I could break this down one time. That is to the power 6x. And this could combine, there is 1 plus 6x. I hope you all follow that. It's 3 to the power 2x. 1 plus 6x is 2x. Move the 2x, move the 1. 6x, take away 2x is 4x is minus 1. And x is minus 1/4. Moving good so far. The value of x for which 4 to the power, which I can see that is x plus 1, that is x plus 1 is equal to 2. That is 2 to the power 2 into x plus 1 is 2 to the power 1. So 2x plus 2 is equal to 1. Move the 2 across. 2x is minus 1. X is minus a half. Answer is A. The value of x such that this is equal to 2 is, I could combine the left-hand side using my laws of logs. I'm going to get log of 5x plus 1 divided by 3x take away 5 to base 2 is equal to 2. Use the log to indice. I get 2 to the power 2 is 4 is equal to 5x plus 1 over 3x minus 5. Cross multiply. 12x minus 20 is 5x plus 1. Move across, move across. 12 minus 5 is 7x is 21 and x is 3. Right, this is a nice question as well. Very, very beautiful question number 16. This series converges to, we don't need this no more. When we converge, we calculate the sum to infinity, which is a over 1 minus r, as long as the modulus of r is less than 1. So 4/3 divided by minus 2, 4 over 3. 4 over 3 divided by negative 2. That is negative 2/3. It does work, and I believe this was a repeat question. So this is going to be minus 2 over 1 minus 2/3. That is 1 plus 2/3. And minus 2 divided by that, it's going to give me minus 6 over 5. The answer is A. The sum of the first n terms of a series is given by this. The sum of the first 10 terms is, so if this is the sum of the first n terms, then the sum of the first 10 terms occurs when n is 10. So I'm going to have the summation when r goes from 1 to 10 of 5 minus 3r. Now we can do this the long way, or we can do this the short way using probably a AP or a GP. We could go and plug in r is 1, r is 2, r is 3, 4, 5, 6, 7, 8, 9, 10, and then go ahead and add up all those numbers. Or let's get the first term when r is 1. When r is 1, I'm going to get t1, which is term 1, which is 5 minus 3, which is 2. Term 2 is going to be when r is 2. So 5 minus 3 into 2 is minus 1. And just to check if it's an AP or a GP, I'm going to calculate T3. T3 is going to be 5 minus 3 into 3. Minus 4. And let's check and see what my common difference is. And if the common difference exists for these two terms, and then for these two terms, well, I good to go. Alright, so T2 take away T1. Minus 3. T3 take away T2. Minus 3. So this is definitely an AP where D is minus 3. So S sub 10, we could be n over 2 into 2a plus n minus 1d, or a plus l. That's going to be 10 over 2 into 2 plus the 10th term occurs when r is 10. 5 take away 3 into 10 minus 25. So 2 take away 25 is that, multiplied by 5 is minus 115. So the answer, this is C. The sum of this, so this is just a third, 1 plus 1/2 plus 1/3. 1 plus 1/2 plus 1/3. 1 and 5, 6, or 11 over 6. Remember, we are plugging in k is 1, then k is 2, then k is 3. This is where I end. Number 20. The first 4 terms of a convergent GP are that, and that. The sum to infinity is S of infinity is equal to A over 1 minus R. Yet again, let me get R, 200 over 500. Like 2/5 or 0.4. We go up with the 0.4. That's R. So we have 500 over 1 minus 0.4. 1 minus 0.4 is 0.6. 833 and change, or 2500 over 3. Answer is D. This is another repeat question if I remember correctly. A line L passes through the point 6,5 and is perpendicular to a line whose equation is this. The equation of L is, so first let me get the gradient of this first line here and then get the gradient of the perpendicular line L. So if I rearrange, I only focusing on the coefficient of x. Send the 3 across, it becomes minus 3. Divide by the 4, I get minus 3/4 is the gradient of this line here. So the gradient of L is just going to be 4 over 3. And the point passes through 6,5, so we're going to have y take away x1, y1. Y take away y1 is equal to 4 over 3 into x take away x1, which is 6. I'm not going to fight up to see which one of these gradients is 4 over 3. I'm just going to calculate the equation. Y is equal to 4 over 3x. Take away 3 could go into 6 2 times. 4 2s are 8 plus 5. Y is equal to 4 over 3x minus 3. Multiply everything by 3. 3y is 4x take away 9. So if I rearrange properly, I move the 3y on this side here. I'm looking at my answers because it have plenty variations in which I can have this equation. Plenty. So I just browse in my answers and at the same time I'm looking to see what I have. And the best answer that could work for this is when I bring the 3y across and it becomes minus 3y. So A is the answer. The lines intersect at the point P. The coordinates of P are, again, this is another case where you could substitute all of these points into each equation, but the easier thing to do is just go ahead and solve them simultaneously. I can look at the equation, the second equation, move the y on the next side, and I'm going to get 3x take away 5 is equal to y. Looking at the first equation, 7x take away 4y. And based on the first equation, I now have y is 3x minus 5 plus 25 is equal to 0. 7x take away 12x plus 20 plus 25 is equal to 0. 7 take away 12 is minus 5x. 20 plus 25 is 45. Move the 45 across, I get minus 45. I get x is 9. Positive 9. So the answer is C. It's the only question, the only answer, that has positive 9 as a solution. A circle has center, that, and radius 4. The equation of the circle is, so x squared minus 2 fx plus y squared minus 2 gy plus c is equal to 0. This is one way in which we can go ahead and get the equation of the circle. Plugging in the center of the circle, which is 3 and minus 2. You're actually plugging in 3. You're plugging in the minus 2 here. The problem here is we have the radius is 4 and we will use the radius to go ahead and calculate this value of c. Now this is one way to do it. No problem. What we could do here, right? And watch. This is going to be x squared minus 6x plus y squared plus 4y plus c is equal to 0. I look in here to see which part I go have a minus 6x and a plus 4y. I have it here, minus 6x and plus 4y. So the answer is going to be C. So you could use these forms of the equations to get the answer without even calculating what the value of c is. Now, to calculate c, we know that how the radius r is the square root of f squared plus g squared take away c. I can rearrange and solve for c because I have r, I have f, and I have g. So if you want, you could go ahead and do that. We will get 3. Another way is just simply x take away a squared plus y take away b squared is equal to r squared. Expand, rearrange, and you get your equation of your circle. Two vectors are equal if they have the same magnitude and different directions. They have the same magnitude and the same direction that you want to gravitate in towards over A. Are parallel are in different directions. Have different magnitudes? No. So I'm going to go with B. B is the most applicable answer for number 24. A triangle OAB has vertices given by these 3 points respectively. Given that the angle between AO and OB is pi on 2. Okay, so there's a dot product case here. So one thing that could help us here is having a diagram, right? I have the vertices of a triangle. And let me just say this is A, this is O, and this is B. They say that this angle here is pi on 2. Which means if I dot this AO dotted with OB, I'm going to get the angle in between it. Now AO is equal to negative OA. Now if the triangle has vertices given by this, this, and this, then this here is the center. Cool? So I'm going from O to A, which is minus 3A. Negative OA is going to be negative minus 3A, which is equal to 3 negative A. And OB is just 6, 2. So 3 minus A dotted with 6, 2 is equal to the modulus of, let me call it, we will say OA, the modulus of OB, cosine of pi on 2. What is cos pi on 2? Cosine of pi on 2 is 0. So these two here, these two lines are perpendicular to each other. So dotting these two things, I'll dot the x's, which is 18. Dot the y's, I get minus 2a is equal to 0. Move it across, I get a is equal to positive 9. If all have questions, voice them in the comment section below. Given that OA is this and OB is that, the vector AB, the resultant vector case, AB is AO plus OB, which is minus OA plus OB. Minus OA could be 17 negative 25. OB is 4, 5. 7 and 4 is 17 and 4 is 21. So which one gives me positive 21? D. You could double check the second value as well. Minus 25 plus 5 is going to give me minus 20. And we're good to go. Which of the following formulae are used to calculate the area of a sector with radius r, arc length L, and angle Q in radians? So we want the area of a sector is a half r squared theta. The sector is A, is a half, the radius is r, and theta, the angle, is going to be Q. A half r squared Q, or r squared Q over 2. R squared Q over 2. L squared over 2Q. So I know for sure 1 is part of the answer. So it could either be 1, 2, or 3. Now, the arc length L. How are you utilizing the arc length L? We know that the arc length L is equal to r theta. So if I try to replace something inside of here with L, R is equal to L over theta. All right, so this could be a half R squared, which is L squared over Q squared multiplied by Q, because this here is R squared. Cool. U could cancel with U, and I get a half L squared over Q, or L squared over 2Q. So 2 is a part of the answer as well. So it could be either this or this. And what about LR over 2? This one we do not have the angle in the part 3. You don't have the angle as part of the formula. So theta is equal to L over R. So I can rub this off. So A could be a half R squared. Q is the angle. L over R. The R cancel with the R. We get RL over 2. So RL, LR over 2. So all works. The answer is D. Nice question. If I get this one correct, I think that deserves a like on the video. The size of the missing angle in radians is, all right, no scene, 34 plus 110, 144 was the missing angle in degrees, 36 degrees. And I had to multiply by pi over 180 to get my answer in radians. And I'm just going to check and see how much times 36 could go into 180. 5. Pi on 5. A. All right, sine x completes 1 revolution in 2 pi radians. The answer is D. For this, the equation has one real solution given by sine x is equal to negative a third, cos x, sine x, and cos x. All right, now trying to figure out a shortcut in which we can do this, right? Yes, we could try to substitute these values inside of here, but if I substitute sine x inside of here, I still have a variable x, so I have no choice but to go and solve this my quadratic way. Sine squared x is 1 minus cos squared x. 3 into 1 minus cos squared x is 8 cos x. I'm moving everything across on the right hand side. So I'll get negative 3 cos squared x moving across. I get 3 cos squared x plus 8 cos x. Move the 3 across. I get minus 3 is equal to 0. Has one real solution given by, so let me solve this quadratic, right? Now this is a quadratic, whether you make a substitutions for cosine theta or not. Mode 2, 2, 3, 8, and minus 3. One answer is a third. So cosine x is equal to 1/3. What's the next answer? Negative 3. I could have cosine x is equal to negative 3 as well, but this will not yield any solutions. So cosine x is equal to 1/3 is the only one of these solutions here. Right, pretty nice question. Sine of theta plus 45 degrees is equal to, again, this is a repeat question. Was it theta plus 45? Let me check and see. 2018. This is where we would have used the substitution for 0.1234 in the previous question. This is sine of alpha, the angle, take away 45. This time is the angle plus 45. Previously, it would have been a minus separating it here. So naturally, you could think it could be a plus. 1 on root 2 sine alpha plus. 1 on root 2 sine alpha plus. So the answer is A. Tan of this is equal to, all right, so in the event that you don't remember your compound angle formula for tan, you could do one of two things. You can make a substitution inside, or you could change tan to sine on cos, and then use a compound angle formula for the top, compound angle for the bottom. Or you could use a compound angle formula in the beginning to get tan of a plus b. So let me go through the route where we forget what the compound angle formula is for tan. Make a substitution for the value of the angle, because these things will work for all values of the angle. Now the tan curve for 90 degrees, it ever works. So pick anything other than 90 degrees, right? So let me pick x is equal to 0.3. Just making up. X is 0.3. So it doesn't matter if you work in radians or degrees, it does not matter. Inside of here, go be actually it matters because we have pi in the mix here, so you have to put it in radians. Sorry. So you're going to have tan of 0.3 plus 2 by 0.3 plus pi on 4. 2 into 0.3 plus pi on 4. And it's tan of this. All right, and it's done. 5.331855223. Now remember, x is 0.3. Tan of, now you see, I don't know if this is tan of 2x plus 1, or if it's tan of 2x, then I add in 1. Let me check both cases, right? Let me pick 2x to be the angle alone. 2 into 0.3 plus 1. Definitely cannot work. Let's try 2x plus 1 to be the angle. 2 into 0.3 plus 1, close bracket, negative. So either way, A could not be an answer. Next, tan 2x minus 1 over 1 plus tan 2x. Now, 2 into 0.3 is 0.6. So if you realize, every time here, I have tan of 2x coming down the road. So I know like 0.6. So I'll have tan of 0.6, take away 1. I have a negative number. I don't know if the denominator will yield another negative for it to be a positive. I don't know. 1 plus, wait. Yeah. 1 plus tan of 0.6. Did I use tan of 0.6 in the beginning? I can't remember. Yeah, I did. Tan of 0.6, take away 1. Okay, I did. So B is not the answer. Tan of 0.6 plus 1 divided by 1 take away tan of 0.6. Ha! 185522. Right. C is the answer. So for questions like this where we can't remember, you don't have to leave it out. Yes, you're going to spend a couple more minutes on it, but you don't have to leave it out. All right, you have an hour and a half, which is 90 minutes to do 45 questions. You had 2 minutes a question. So for example, we are on question 32 and I have been speaking, I have been explaining stuff, and we only 38 minutes into the video. So we have enough time to finish a paper. Easy peasy. This is a question we did previously. The answer for this is A. You could trial and error it, or you could go through the long way like what we did before. And let me go back just in case some of you are watching this video before or you're watching the next one. Where was that one? That one would have been, look at right here. All right, so we trial and error and we get 35. X plus 20 is cos x. Sine of x plus 20 is equal to cos x. Sine of x plus 20 is equal to cos x. Where we would have used the compound angle formula, expand this out here, bam shot, then rearrange, get all the x's on the trigs, simplify it down, and go back in the previous video and look at number 30. Tan theta is 413, the exact value of tan 2 theta. Now there's a, oh boy. Now, oh god, I forget what the double angle formula for tan is. Now tan 2 theta is not tan theta by tan theta. It's not tan of 2. It's not this by 2. So let me get the compound angle formula for tan, right? I myself forget the double angle formula for tan. Right? Yes, even teachers forget sometimes. Right, so tan 2 theta is 2 tan x over 1 minus tan squared x. Right, so tan 2x is equal to 2 tan x over 1 minus tan squared x. Another thing we could have done here is say, well, you know, tan theta is sine theta and cos theta. We could actually complete a triangle for this. So we have a little contingency plan, right? And I'll think about that. So if tan theta is equal to 4 over 3, so, oh god, I think we had to go through we had to go through this. Tan theta is 4 over 3. We could have do it. Yeah, we could have do it. We could have used this. Let me use this here. Right, so we have tan 2 theta is 2 tan theta, which is tan theta is 4 over 3, over 1 minus tan squared theta, which is 4 over 3 squared. This is going to be 8 over 3 divided by 1 take away 16 over 9. We get a calculator. I am anticipating a negative number. 8 over 3 equals divided by 1 take away 16 on 9 minus 24 on 7. The answer is C. Now the next way we could have done this, right? In the event that we forget, like what happened just now, we forget what the double angle formula is for tan. We know that how tan theta is equal to sine theta over cosine theta. Right now, 4 looking like the sine theta, 3 looking like the cosine theta. So I could say that how sine theta is 4 and cosine theta is 3. But nah, that ain't gonna work. Alright, that ain't gonna work. The triangle go harder work here, right? So tan theta is opposite over adjacent. Draw your triangle. We have theta. We have the opposite, which is 4. We have the adjacent, which is 3. This is a Pythagorean triplet. This is 5. Sine theta is 4/5. And cos theta is 3/5. Tan 2 theta is equal to sine 2 theta over cosine 2 theta. Sine 2 theta is 2 sine theta cos theta, which we remember. And cos 2 theta is cos squared theta minus sine squared theta. This is 2 sine theta cos theta divided by 2, well, cos squared theta, which is 3/5, squared, take away 4/5 squared. So let me see what we get. 2 into 4/5. Oh, my calculator across. 2 into 4/5 into 3/5. Then my numerator, 24 and 25, divided by 3/5 squared, that is 9 on 25. Take away 16 on 25. I get the same thing, minus 24 over 7. Right, this way is the longer way. Just write down what the double angle formula is for tan. Because I do not, I never check and see if we get formula sheet here. We don't get a formula sheet. So, in the event that we didn't get in the event that we forget, you could go through this method as well. The differential of this is 7x squared plus 4 to the half. Differentiating half into 7x squared plus 4 to the minus a half multiplied by the differential of the brackets, which is 14x. 14x by a half is 7x. So I expecting 7x on top, either this or that, over, and I expecting to get the square root of 7x squared plus 4. Square root of 7x squared plus 4, the answer is D. No, sorry, B. At the 0.74 on the curve, dy dx, and that is that. The 0.74 is, alright, so given that dy dx is equal to 0, that means we have a stationary point. The second derivative is -5. Given that this here is -5, we sad, bam shot, so we have a maximum point. Where's that optimum point? That's interesting. What is an optimum point? Let me see. Right, so both of us learning, well, all of us learning something today. Optimum point meaning. Mathematics. Apparently it have plenty meanings. There's programming, no. Optimum point calculus. Nah, I just seen optimization problems and things. What is an optimum point? Optimization or finding maximum or minimums of a function? Nah. No. Alright, so yeah, the first derivative is equal to 0 and the second derivative is equal to -5. Now, a stationary point occurs when dy dx is equal to 0, which happening? Dy dx is equal to 0, and the second derivative just states the nature of the stationary point. This is a repeat question, I believe. The differential of cos is negative sign, so we're looking for negative sign of pi on 6. My calculator's are already in radians. Negative sign of pi on 6. -1/2. Y is equal to cos 2x. When I differentiate cosine, I get negative sign. And I must multiply by the differential of the angle. So we get -2 sine 2x. The gradient function of the curve is, so again, we will change the sine to cosine. It's a nice question. Change the sine to cosine, leave the angle as is, and I had to multiply by the differential of the angle, which is going to be 4x. 4x cos 2x squared plus 1. Alright, the common misconception here, when I differentiate a trig, in this case sine, when I differentiate sine, it just changes the cosine. It doesn't work like that. Yes, the differential of sine x is cos x, but I am multiplying this by the differential of this angle. So when I'm differentiating a trig, just so you all know, if I have the trig being y is equal to sine of some function of x, it could be x, it could be 2x squared plus 1, dy dx, and it works for cosine as well, right? The sine changes to cosine of f of x, but I have to multiply this whole thing here by the differential of the angle. I have to multiply by the differential of the angle. Similarly, if I differentiate in cosine, it changes to negative sign, but I still have to multiply by the differential of the angle. Right, write that down. Pause it and write it down. The region bounded by the curve, the x-axis and the lines is rotated 360 degrees about the x-axis. So I'm looking for volume is equal to the integral of pi y squared dx. The curve is y is x squared. So y squared could be x to the power 4. Pi x to the power 4 dx between 1 and 0. They just pull the pi on the outside, so the answer is D. Similar question to something we did in the last paper. 2x take away 5 cubed. Integrating one time. Adding 1 to the power, dividing by the new power, and I have to put the differential on the denominator, the differential of the brackets, right? So we have 8 on the denominator. We obviously we're plus in the c. We have 8 on the denominator and we have 4 as the power. So the answer is c. All right, 42. The integral of sine. Again, I like to do it like this. Where did I do it? I didn't write it down. If y is equal to cos x, dy dx is equal to negative sine x. So when I integrate sine, I get negative cosine. So when I integrate this sine, I'm going to get negative cosine x. And when I integrate cosine, I'm going to get sine x. And it was already negative cosine. So I just put back the minus, and the integral of cosine is sine. So minus cos x minus sine x. Minus cos x minus sine x. Obviously, we have to put in the constant c. Let me go back. Let me go in the paper here. C was the scene. Right, sorry if you all heard that just now. That is just, I played the last video by mistake. This is number 43. That is a and 2, 6 plus 3x. A and 2, 6 plus 3x dx is equal to 72, where a is more than 2. All right, so let me go ahead and integrate this. We're going to get 6x plus 3x squared over 2. Evaluated between a and 2 is equal to 72. Plug in a, I'm going to get 6a plus 3a squared over 2. Take away, plugging in 2, I'll get 6 2s are 12, plus 2 2s are 4. 4 by 3 is 12. 12 divided by 2 is 6. Let me do the magic. I'm going to get 6a plus 3a squared over 2. Take away 12 and 6 is 18. Move the 18 across. I'm going to get 72 plus 18 and follow the string of operations here, guys. 72 plus 18 is 90. And then I'll multiply everything by 2 to get rid of this denominator here. So I'm going to get 12a plus 3a squared, 90 by 2. I checking it, you know. 180. Now I could divide everything by 3. Or I could just go ahead and solve this fella. They say a is more than 2. So mod 2, 2. The coefficient of the variable is 3 of x. Well, in this case, a squared is 3. 12. When I move this across, it becomes negative 180. 6 and negative 10. So we will only take 6 as the correct answer. If x is equal to this, now, we don't need this no more. Watch this, right? This is a nice question. It comes very, very often, extremely often. If I have a graph, actually, yeah, let me have a graph, right? And let me have a curve, and let me call this curve f of x. And I have my two limits. And the two limits are b and a. I can say that this shaded region here, the area of that shaded region is the integral of b and a between b and a of f of x dx. Everybody good with that? Now if I include another piece, and we call it the c, where a is less than c, and I'm translating it from this here, and c is less than b. It is still the same area, but now it's separated into two pieces. Where I have this area, which is the integral between c and a of f of x, plus the integral between b and c of f of x. And this is the integral between b and a of f of x. Obviously, I'll leave out the dx for now. Okay? So, I'm looking for limits where I have... Now, I see a 0 here. So, we just one shot, ignoring that one time. Looking at the second one, I see in C and A as my first two, and then I see in C and B, which ain't going to work. I see in C and A, and I see in B and C. The answer is C. Right, I hope this diagram would have cleared up a couple things. If you understand number 44, give me a thumbs up downstairs. And finally, the region R enclosed by the x-axis, the curve y is equal to x squared. Okay, that actually want us to go ahead and calculate this, right? So we are integrating between 3 and 2, x squared plus 2x minus 1 dx are going to get x cubed over 3 plus 2x squared over 2, and I could do this one time, minus x, 3 and 2, plug in 3 cubed over 3 plus 3 squared, take away 3, plugging in 2 cubed over 3 plus 2 squared, take away 2. Let me work out the first bracket. Now, just because it's the last question, do kind of rush it down, right? Take your time and at least get your mark, now, man. 3 cubed over 3, that is just 3 squared, which is 9. 9 and 9 is 18. 18 take away 3 is 15. So I didn't have to get my calculator here. Take away. This one I got how to get my calculator. 8 over 3 plus 8 over 3, I like to put equal, plus 4 take away 2. 4 and 2/3, 15 take away, my 4 and 2/3 is 10 and a third. 10 and a third is 31 on 3. So the answer is B. So, hopefully, that clears up 2019, I believe. 2019. We still have 2021 specimen and 2023 to do. So we have 2 more papers. Look out for the pure maths ones for those guys who are doing pure maths. I'll add maths first, then is unit 2. So I'll do the unit 2. Those of you all who are also interested in the pure maths lessons, just give me a message. Right? Message on WhatsApp 793-4754. All right, once all you do all your work with me for pure maths, guaranteed distinctions. All right, guys.